Hello, in this video we will see how can we analyze a water distribution network by using EPANET software. This is the data we got. We got data regarding pipe lengths and diameters, and we have Hazen-Williams reference coefficient of 10. And we will create this water distribution network in EPANET software, and we will analyze it. When I open EPANET software, this is how it looks like. It's an empty page, and we have to create that water distribution network in this space. First, the steps that involve in this problem is, first we will create nodes. These are the nodes. Node is the point where one or two or more pipes joins. This is the node. This is the node. This is the node. This is one more node. Like that, we have 6 nodes. We have 6 nodes, and we have 7 pipes. And so we have to create 6 nodes in EPANET software, and we have to connect those 6 nodes by using 7 pipes. First, we will see that what are the default units in this EPANET software. This is the first and important thing that one has to do. We will see the units by defaults units. We'll go to project, go to defaults, go to hydraulics, flow units. As we are going to use SI units, it should be in liter per second. And we are going to use Hazen-Williams equation. So it should be HW. If you are using Darcy-Weisbach equation, you can use DW. If you are using Chesy and Manning's equation, you can use CM. As we are going to use HW equation, so Hazen-Williams equation, you can click on HW, click on OK. Now we are ready to set the nodes and pipes. I'm going to click on this add node or junction. If I click anywhere on the screen, I'm going to add one junction or node. If I click here, this is my one node. If I click here, this is another node. If I click here, this is another node. Like that, we need 6 nodes. This one, and this one. Okay. Now we have to connect these nodes through pipe. So if I click on this add pipe, now I am ready to add a pipe between any 2 junctions. So I will click from where my pipe starts. My pipe starts from here. So I'm going to click on this junction, and it will end here. So we'll click it. This is like that. I can add pipes. Pipe here. There is one more pipe here. There is one more pipe here. Now we will see the properties of these pipes. Okay. This pipe ID is 7. Here it is given. Pipe ID is 7. And this pipe ID is 3. This pipe ID is 5. This pipe ID is 1. So if I click here, edit. This is the table which opens. So here pipe ID is, what is the pipe ID of this pipe? It is 7. So we will change it to 7. And what is the length and diameter of this pipe? Length is 200, diameter is 400. So length is 200, diameter is 400. Now we'll move to another pipe. This pipe ID is 3 and length is 200, diameter is 400. This pipe ID is 3 and length is 200, diameter is 400, and roughness coefficient is 100. I forgot to mention that, here roughness coefficient is 100. Okay, if it is 200, this HW roughness coefficient, HW roughness coefficient. If it is 200, you can change it to 200. But as we are having 100, I'm not going to change this value. Okay. Now we will move to another pipe. This pipe. What is the idea of this pipe? Idea of this pipe is 5, and length is 200, diameter is 400. So idea of this pipe is 5, length is 200, diameter is 400. We will move to this pipe. ID is 1, length is 200, diameter is 400. Now we will add remaining pipes. We have a pipe between these two junctions, and there is one more pipe between these two junctions. And we will add the length and diameter of these remaining pipes. We will start from this pipe. If I click on this pipe, it will open start node and end node. What is the diameter of this pipe? This is diameter is 400, length is 400. Diameter is 400 and length is 400. And pipe ID is 4. Pipe ID is 4. Pipe ID is 4. Diameter is, length is 400. Diameter is 400. You will see next pipe. This pipe ID is 2 and diameter is 400 and length is 400. Pipe ID is 2, diameter is 400 and length is 400. Length is 400 and diameter is 400, and roughness value is 100. Here pipe ID is 6. Pipe ID is 6. Length is 400 and diameter is 400. That's it. I think we gave all the data to the pipes regarding diameter and length. Now we will give it demands at various nodes. What are the demands at various nodes? If you see this node, there is a demand of 300 liters per second. At this node, there is a demand of 200 liters per second. At this node, there is a demand of 500 liters per second. And the head that is need to be met at this node is 10 meters. The head that is need to be maintained in this node is 10 meters. So if I go to data, I go to junctions. At this junction 1, what is the demand? Base demand. Base demand is, this is my junction 1. What is the demand here? 500 liters per second. Okay, and I am assuming that all these nodes all these nodes are at same level. All these nodes are at same level. So elevation is going to be 0. Okay. Now, if I go to this node, what is the demand here? That is 300 liters per second. Go to this node, base demand is 300 liters per second. If I go to this node, there is demand of 200 liters per second. 200 liters per second. Okay. Still, is there anything that we need to incorporate? Still, we need to add this head. There is a head of 10 meters at this junction. To add this head, what we have to do is we have to create a reservoir. We have to create a reservoir. We have to create a reservoir at upstream of this node, create a reservoir, and we have to connect this reservoir and junction. We have to connect these reservoir and junction through pipe. Add a pipe between reservoir and junction. Now, connect these reservoir and junction. Important thing that is need to be noted down here is length of this pipe is to be very, very small, because whatever the head available at this reservoir must be same as the head available at this node. Okay, head loss is directly proportional to length and inversely proportional to diameter. So if we take lesser length and if we take length of the pipe as small and diameter is large, you know, we can minimize the head loss between this reservoir and node. Okay, so what we will do is that we will take this length of pipe as 1 meter and diameter as 1000. Okay, so that the head, no head is going to lost between the reservoir and node. Now we'll go to this reservoir. What is that total head at this reservoir that is needs to be maintained? It is going to be 10. I'm going to click on OK. That's it. I think we assigned all the data to the water distribution network. Only thing we are left with is we have to run the analysis. This is very, very important thing. Whatever the head available at this reservoir, that should be same as the head available at this node. Okay, that's why we are using a smaller length pipe and which is larger in diameter. The pipe has to be larger in diameter, but its length should be small. Okay, now we will run the analysis. We will see the results. The run is successful. We will see the results. Go to view, options, links, label, click all these. I'm going to use filled flow arrow to show the direction of flow. You go to map to see the results. You go to map. You go to, if you want to see the you want to see the head at every junction. If you want to see the head at every junction, you can check this. These are the head values at these junctions. You want to see, if you want to see the flow through every pipe, to each pipe, you can use this. This is how, We can use EPANET software. You can see the results in table also. You can see the results in table also. You can import these results. For greater visual appearance, you can use this. You can play with this. If you want velocities, you can see this. If you want base demand, you can see this. This is elevation. We know that we are assuming that all the nodes are at same elevation. So elevation is going to be 0. We can play with this. Thanks for watching.